Hello and welcome back to another episode of Math with Sohn. Today we're going to be adding and subtracting rational expressions, which is not that bad. So let's get into it. So you would really hope that when you're adding and subtracting rational expressions that the bottom of the fraction is already the same like it is here. Because then your job is a lot easier, because once the bottom of the fraction is the same, all you have to do is, if it's adding, combine like terms on the top of the fraction. So 5x and 1x makes 6x, and 2 and negative 1 makes positive 1. And then we have the bottom of the fraction, x squared plus 10x plus 25. Now you don't have to always factor the bottom of the fraction, but it would be a safe idea to think, at least at the bare minimum, if it did factor, which it does, it's x plus 5 and x plus 5, would the top of the fraction simplify or cancel? And the answer is no. So you could leave it right there with the x squared plus 10x plus 25. All right, another one. This one looks a little different, but it is no different. The bottom of the fraction, even though it's already factored, has a 5 and an n plus 3 and a 5 and an n plus 3. So because the bottom of the fraction is the same, again, we just combine the top. N plus n makes 2n. Negative 1 and 2 makes 1. Ask yourself, will anything cancel off? And the answer again is no. It's very rare when it does happen. When it does happen, I get very excited. All right. Our first subtraction problem, not only is it our first subtraction problem, it's also the first problem that does not have a least common denominator. Now, my recommendation is to always look and see if there's any simplifying you can do ahead of time, because it might make your life a little easier. It doesn't happen very often, but it does in this case. If you look, x over x is gone. And 6 divided by 2 is 3. So we really have 3 over y squared minus 2 over 3. And here, the bottoms for the first time ever are not the same. So my recommendation is multiply by what you are missing. Over here, we have a 3, but we are missing the bottom part of a y squared. If we multiply by y squared and y squared, I would get 3y squared. And over here, I am missing on the bottom a 3. This side had a 3, the y squared does not. So I've been multiplying by 3 over 3. This would make 9 over 3y squared minus 2y squared over 3y squared. And then you could subtract the top of the fractions, but not really, because they don't actually combine nor subtract. But you would end up with 9 minus 2y squared over 3y squared for that one as the final answer. All right. The next one, this is a more typical rational expression where you have two factors and they're both very different, because rational typically means that you're going to have fractions on the bottom. So here, again, you multiply by what you're missing. We are missing a b plus 2. Excuse me. Oh, my goodness. I got to rewrite it now. We are missing on the 3b plus 5 side a b plus 2. And a b plus 2. So we're going to multiply by that on the top and the bottom. That dot should probably go more right there. And then over here, where we have the minus, I would recommend anytime you're subtracting to change it to a plus and then make that a negative 6. That would help yourself out a lot. So over here, we're missing the 3b plus 5 and the 3b plus 5. So look at the bottoms. The bottoms are now the same. We had a b plus 2. We multiplied by the 3b plus 5 because that was what we were missing. We had the 3b plus 5, and we multiplied by the b plus 2s because that was what we were missing. We are going to distribute the top of the fractions. That would make 2b plus 4. And the bottom, I do not ever recommend foiling. I would recommend keeping it in factored form until all other options have been exhausted. So we have just kept the bottoms the same. Distributing the negative 6 would make that a negative 18b minus 30 over the b plus 2 and the 3b plus 5. And again, this left side of the factors are the same on the bottom, and the right side, the bottom is the same, the denominator. So we are going to add the top of the fraction, the numerator. 2b and negative 18b makes negative 16b. 4 and negative 30 makes negative 24, 26. All over b plus 2 and 3b plus 5. Now, I would recommend, in this case, factoring the top out. If it was a 24, I bet something would have happened, but it's not. We can divide both of these by negative 2, and that would give us 8b plus 13, which was close to canceling out with something, but nothing actually simplifies. So in this case, we didn't really have to factor out the negative 2, but it's always a safe idea to factor ahead of time just to see if anything is going to happen. Okay? Let's see what else we got. We got, number 6. I skipped one. I didn't like it. So on number 6 here, what I would highly recommend, anytime before you were like, let's multiply by what you're missing, it'd be a lot harder to multiply this by a 2x minus 2 than if we were to factor the problem first. Always factor the problem first to see if it will help. And if it will, then we keep it that way. I also made that negative 2 a negative 2 on the top and changed it to a plus. And ask yourself, would you rather multiply by 2, x plus 1, and x minus 2? Would you want to have to deal with all three of those or just the first two? And if you know the answer to that question, then you would do that. In this case, it didn't really help to factor because we were, right off the get-go, missing the 2x minus 2 and the 2x minus 2. And on the other side, we were missing the x minus 2 and the x minus 2. A lot of people, what they do here is they try and multiply by 2 to make the 2x minus 2 part, but that doesn't work. So we're going to end up foiling the top of the fraction. We're going to avoid this factored version because we got x minus 2 times x minus 5. I'm going to write it up here. That would make x squared minus 5x from x times negative 5 minus 2x plus 10. And then the top of the other fraction would be plus negative 4x plus 4. Both of these are over their very own individual x minus 2 and 2x minus 2 and x minus 2 and 2x minus 2. Okay? Now when we combine the top of the fractions, because there's a plus sign in between, we have negative 5x and negative 2x and negative 4x. If you combine all of those, you get negative 11x. And then plus 14 with the x minus 2 and the 2x minus 2. Okay? I got one more for you, ladies and gentlemen. This one last one is what I would consider the most typical problem, but it wasn't one that I could find on this worksheet, apparently. So let's say we had 2 over x squared minus 9 plus 5 over x squared plus 3x minus 18. Okay? This is a very typical type of problem where it would be very, very silly to multiply the top of this one by x squared minus 9. This is silly. Do not do this. That would work, but it would be really silly. Okay? And over here, you don't do that. Factor first, because you never know. If we factor first, the x squared minus 9 would be x plus 3 and x minus 3. It multiplies to negative 9 and adds to 0. Plus 5 over what multiplies to negative 18 but adds to 3. That would be positive 6 and negative 3. Here's the huge thing. They both have an x minus 3. So we aren't missing an x minus 3. We are, however, missing on the right side an x plus 3 because x plus 3 is over here but not over here. And we are, however, missing on this side an x plus 6. So we would only have a little thing to multiply by. We end up with 2x plus 12 over x plus 6, x plus 3, and x minus 3. And we have to add that with 5x plus 15 over x plus 6, x plus 3, and x minus 3. The bottom of the fraction is the same, so we are going to add the top of the fraction together. We get 7x plus 27 over x plus 6, x plus 3, x minus 3. And there we go, ladies and gentlemen. That's going to do it for this one. We still have another video coming out that's going to be dealing with some extreme cases, okay? But that's going to do it for this one. I will see y'all later. Bye.